Want to provide you with some help on the section 1-2 homework, and I've just selected a few problems here that I hope will be of some help to you. Here's number 21 on page 17. The directions are to solve the inequality, solving the inequality for z, and then we're going to show the solution on a number line. Okay, so we know from our solving of linear equations, we solve linear inequalities in the same process. We follow PEMDAS. Remember, our PEMDAS order is being followed in reverse. Okay, so the first thing I'm going to do is undo adding 18. So I'm going to subtract 18 from both sides. And here is the result. Next, still thinking of reverse order of PEMDAS. Some people would get a little confused here, but remember, division by 4 into this numerator, it has to be into the entire numerator. It's all of it together. You cannot separate these parts. Therefore, you'll probably help yourself avoid making a common mistake. Since this has to be treated as a group in the division, let's just go ahead and put grouping symbols, parentheses, around the numerator. So now I'm going to undo in this order. I'm going to undo the division first, and then I'm going to take care of the parentheses. So the way I undo dividing by 4 is multiplication by 4. And that gets me to this point. Now I'm down to two operations, addition and multiplication, and I'm going in reverse order. I undo addition first, and then I can divide by 9 or multiply by 1/9 to get to my solution, which is really a range of numbers, all the numbers that are less than 3. And since it doesn't say or equal to, then 3 is not included. So here's how your typical way of doing these number line graphs. We're going to put 0, we're going to put the number's relative position to 0, and then we're going to put an open circle above 3 to show that it is not part of the solution, but all the numbers less than 3 are. So that would be a good way of showing the overall solution to this inequality, all the numbers less than 3. Okay. Let's move on to number 22, which is a good little word problem for this gymnast. Reading through this carefully, maybe reading through it 2 or 3 times to make sure you grasp what is being asked for. Basically, this gymnast has a score that apparently is most they can score is 10, and the score is made up of 2 different components. There is a technical score, what is their technical ability to perform all the moves, and then there's an artistic score, how creative were they, and the combination of those 2 aspects of gymnastics will go together to make a total score out of 10. Okay, so what they're wanting us to determine is what is the artistic score that's needed to get a final score that's at least 8.0. Okay, so whenever you're asked a question, you need a variable to represent the answer to that question. So I'm just going to pick the variable x, and x is going to be the necessary or the needed artistic score. So we've defined a variable to basically answer the question that's being asked. Okay, now let's see if we can work through some of this. Let's go back to this technical score, because 75% of the overall score is made up of their technical ability. And they've already achieved a score of 7.6 on the technical ability. Well, let's just go ahead and, if you need to take your calculator, let's find out what 75%, oh, sorry about that. Let's find out what 75% of 7.6 would be. 75% of means multiplication. So we need to find out what that number is. That is 75% of 7.6. And I'm going to grab my calculator here. 7.6 times 0.75, and it looks like it's 5.7. Okay, so we know the points for the technical portion. That's not a guess. What we don't know is what is it going to take, what score, which we've represented as x, times 25% will get us at least, the question is at least an 8.0. So we need a score times 0.25 added to the already given 5.7 to make at least an 8.0. Well, that represents greater than or equal to inequality. Okay. So let's solve for x. So 0.25x is greater than or equal to, and now you're going to grab your calculator if you need to, and let's do 8.0 minus 5.7, and that's 2.3. And now to solve for x, you can divide by 0.25 on both sides. So dividing that by 0.25, and we get a 9.2. Okay, so to get an 8.0, at least an 8.0, they're going to need at a minimum of at least a 9.2. And so that ends up being the answer. They need a 9.2 to get at least an 8.0 overall score, final score. All right, that takes care of number 22. Number 24 is one of these where we are given a sentence and we're going to convert this over into an inequality statement. The quotient of, that means division, 3 times a number, of course that's multiplication, 3 times a number and 4, is at least negative 16. Well, we ran into this phrase in the previous problem. At least references greater than or equal to. Okay, so the quotient of, there's my dividing line, 3 times a number, we'll just let our number be n, 3 times a number and 4, probably made too long of a dividing line, is at least greater than or equal to negative 16. Okay, so I solved this. I've got a couple of different options. You can undo multiplication by 3/4, which is really what's happening here. We're multiplying n by 3/4, and you can undo that. Remember the inverse property of multiplication using the inverse of 3/4, which is 4/3. Multiply by that on both sides, and you're left with n is greater than or equal to negative 64/3. Negative 16 times 4 is negative 64 over 3. And as far as I'm concerned, you can leave, in this case, you're not graphing, so there's no need really to change this into an improper fraction or a decimal. So you can leave those answers like this. I'm sorry, change it into a mixed number. It's already improper. You can leave fractions as improper. That's fine. Okay, I think I got one more here for you. This is number 34, and we're solving this inequality for n. So to begin with, remember PEMDAS in reverse. We're going to undo division before we undo this group that has to be treated together in the division. It has to be both of these have to be divided at the same time. So I'm going to multiply by 8 on both sides, and that takes care of the denominator. And now I've got to get my n terms on the same side, so I'm going to kill the little one. The little one is negative 3, and so I can do plus 3n on both sides. Alright, so far so good. And now I'm going to solve for n by, you can divide by 11 on both sides. And so we get our answer as negative 15 elevenths. All the numbers that are greater than negative 15 elevenths will make this inequality statement true. That's really what we're saying. So in this case, you probably do want to look at this as as a mixed number. It's already improper, and as a mixed number, if you divide 11 into 15, probably remember how to do this, but just in case, it's negative 1 and 4 elevenths. Okay, so remember how we do fractions on the number line. We don't have to be too fancy, but negative 1 and 4 elevenths is between negative 1 and negative 2. Think about 4 elevenths. It's pretty close to just shy of a half. Half would be 5 over 10. So don't have to be exact, but give me a pretty good estimate where you think negative 1 and 4 elevenths is. And it's an open circle because it doesn't say or equal to, and then we'll shade to the right, the greater than side. Alright, so I think that's it. We've taken care of a few of your homework problems. Oh, I got one more. Sorry about that. Let's go ahead and take care of this one. Let's clear out these denominators by using the LCD. The LCD, the smallest number that both 4 and 5 will divide into evenly, and hopefully you recognize that that's 20. So I'm going to multiply to clear out these denominators. I'm going to multiply by 20 on both sides of this inequality. So let's do it this way. 5 into 20 is 4. Now take 4, think of it this way, 5 into 20 creates 4, and now we're going to multiply 4 times this numerator using distributive. 36z minus 16. So we no longer have to deal with the fraction on the left side. 4 into 20 is 5. And now we're going to multiply 5 times the right side. 5 times 7z is 35z. And 5 times 2 is 10. And so now we got rid of our fractions, and we can solve this pretty easily. Subtract 35z from both sides. Z minus 16 is less than or equal to 10. Add 16 to both sides, and we get z is less than or equal to 26. And sketch your graph. Nothing fancy. Just tell me 0 and then tell me on your graph where's 26. Make sure you make a solid dot because it says or equal to, and then you're going to shade to the left to indicate the less than side. Okay, that's the last one. So I hope that helps, but if not, if you've watched this, again, please make sure you can do them yourself. Put the video away, write the problem down again, just start all over. And that's the only way you're going to get better, and the way you'll be prepared for the test is if you can do these on your own. But I just wanted to provide a little help to get you there, so let me know if I can help you further.